Good morning, students. Uh, in the last lecture, we have covered exercise up to 13.4. Now we are here to complete this exercise 13.5. It's optional. So, question number 1. A copper wire 3 mm in diameter. See, copper wire diameter 3 mm is bounded about a cylinder whose length is 12 centimeter and diameter is this. Means radii will be 5 centimeter. So as to cover the curved surface of the cylinder, find the length and mass of the wire, assuming the density of wire copper to be this. Good question. See, this is the cylinder. I'm drawing is big because it requires thinking. Suppose this is the wire. This wire is to be rolled around the cylinder so as to cover the entire curved surface of this. Okay, so what will be the length of this wire? You need to find the length of this wire. Length of the cylinder is height of the cylinder is given, or you can say that length of is 12 centimeter. So it is height of this is 12 centimeter. Diameter was given 10 centimeter. This diameter 10 centimeter, which means radii will be equal to d by 2 equals 5 centimeter. This is radii. So now see, this is half is radii of suppose r1 of this wire. So this whole will be capital D. I'm assuming that this is D. So see, from there this will be D, this will be D, this will be D, this will be D, and so on. So how much length or the number of turns it has taken to complete the cylinder? Will be given by the length of this h number of turns. Let us assume the number of turns divided by n equals h height of this cylinder upon the diameter of this wire. Height of this given as 12 centimeters. Radii and see, this is diameter, so diameter is given as not written diameter 3 mm. So 3, this is centimeter, this is mm. So which is either you convert this into centimeter, or you can mm, or you can convert mm into centimeter. Answer will be same. Because 1 centimeter is 10 mm. So 3 4 are 12, 40. The number of turns that it will take, these are no units. Number of turns the wire will take to convert the entire cylinder is 40 turns. Now, if you view from the top, you will see this thing. So, the length of this one ring or one turn equals r of this cylinder, which is d by 2, r equal to 5 centimeter. This, so total length of this one, I will denote it with small l. Length of this one turn will be 2 pi r1, not r. is 2 pi r. You can take 2 pi r because I have taken this r, so 2 pi r. So there are total n number of turns, which implies that total length of this will be 2 pi r into capital N, where n is 40. You can see from there, this is known, this is calculated from here. This you can get the value of L. Now in the question it is given that find the length and the mass of length you have calculated. Now the given that density of copper to be 8.88 gram per centimeter cube. See density, let us denote, I am denoting this density rho d. The density of this wire is 8.88 gram per centimeter square. See, this is centimeter square, which means that you need to calculate the area of the wire. Area of the wire used equals, the wire is cylindrical, so pi into r into small into capital L. Total length of the wire, radii of the wire, and pi is constant. Area is a pi 2 pi rl, 2 pi r into L, 2 pi r into L. So r is 5 d was given 3 mm, so r is 2 pi into d was given, so let us assume that this d cancel, pi dl. This is the area in centimeter square. So using this density, you know that density will be mass of wire upon area or volume. Centimeter, see, no, it is given centimeter cube, so we need to find the volume. Don't to find the area, find the volume. Find the volume. No need to find the area, no need to find the volume. This is centimeter cube, so need to find the volume of the wire. Volume of the wire is, you know, the cylindrical wire is pi r square h pi d by 2 square h d diameter. You need to put the values. This is capital L, here h will be capital L. Put the value, you will get the value of volume. So you know that pi sigma density will be is given by mass of the wire upon volume of the wire. This value is given 8.88 gram per centimeter cube. Volume of the wire you have calculated from here. You have calculated from this here. You don't know, want to calculate this, you know this, multiplying the two, you get the mass of the wire. So easily solve the question and get the answer. Next, a right triangle. So a right triangle, one angle is 90 degree. It is also given that this is 3 and 4 other than hypotenuse is made to revolve about this hypotenuse. Find the volume and surface area of the double cone so formed. Good question. Well, these are optional, so every question will be a good question. See. This is 3, this is 4. Other than hypotenuse. This is hypotenuse. So you know that if A equal to this, B equal to this, let us assume it is C. You know that using Pythagoras theorem, C square equal to A square plus B square. C 3 square plus 4 square equal to 5 centimeter. Now this length is 5 centimeter. Now it is made to revolve about hypotenuse, which means that this is revolved like this. So the solid, you can see just that one is this cone, another one is this cone. See, here slant height of one cone will be 3 centimeters. Another one will be 4 centimeter. And what we need to find the volume and surface area of the double cone so formed. Choose value of pi as found appropriate. Wow. Here this is 90 degree. Radius not known, but this height is known. This is the radius. This is 90 degree. See, let us assume that this is theta. A, B, no, not A, B. Let us assume this is P, Q, R, S. In triangle PQRS. PQR. What is P in triangle PQR? Cos theta. Cos theta. Base upon hypotenuse. 3 by 5. Similarly, sin theta. Perpendicular by hypotenuse is 4 by 5. Okay. This is 90 minus theta. 90 and this is theta. Now in triangle PQS, angle PQS, you know that sin theta is equal to Q for this triangle. For triangle PQS, sin theta will be QS upon PS. No, sorry, QS upon PQ. This is perpendicular by hypotenuse. QS you don't know. Let us assume this is QS. What is PQ? Is 3 centimeter. But here from sin theta, from here you know that sin theta value is 4 by 5. So you can replace it by 4 by 5. So this comes out to be QS by 3 equals 4 by 5. So this implies that QS equals 12 by 5. And what is QS? QS is nothing but the radii. This is radii because this is going to revolve, form like this, and this is radii. So you get the value of radius. Radius, that is QS, equals 12 by 5. Now everything you have in this question. See, let us assume that this is L1. L1 you know this is 3 centimeters. This is L2, 4 centimeters. R you already know. So total area of the solid thus formed by revolving this triangle about its hypotenuse is given by, see, first area. Area will be, see here the volume formed is this. So the area will be pi r L1 plus pi r L2. R you have already calculated. L1 and L2 are given. So you can calculate the area of the surface generated. Now next, volume will be, volume is the volume of this cone plus volume of this cone. What volume of this cone is 1 by 3 pi r square h1. Let h1 be height of this upper one, h2 be height of this lower one. So plus 1 by 3 pi r square h2. R is same for both. So this v equals 1 by 3 pi r square h1 plus h2. You even don't need to calculate h1 and h2. So see the sum of h1 and h2. You already know that the total hypotenuse is 5 centimeters, so you can simply substitute the value of this is 5 in this h1 plus h2. Or separately you can also calculate h1, which is nothing but under root r square plus l1 square, and h2 is r2 square plus r square plus l2 square. So directly put the value here and here and get the answer. On next third question, a system internally measuring this and this has this much centimeter cube of water in it. Porous bricks are placed in the water until the cistern is full up to the brim. Each brick absorbs 1/17th of its own volume of water. How much brick can be put in without overflowing the water? Each brick being this, and this. See, every question here will be a good question. Already because it is optional. This is cistern. Has this much of water. Let this is L, B, this is H. It has some water in it. It is also given. Now some bricks are put. I'm changing the color to suit. This is a brick. Let us, this is L1, H1, B1. This is H2, L2, B2. This is brick, cistern. Now the volume of cistern. You can calculate L1 into B1 into H1 centimeter cube. Volume, initial volume, it is having is given the questions something centimeter cube. Volume, how many bricks can you put in without overflowing it made to reach each brick being this is this. This is also given, and it absorbs 1/17th of its own volume. So volume of brick will be H2 L2 B2 centimeter cube. So this is volume brick. So volume of brick, suppose total bricks, number of bricks required is n, and these all are put into here. So the total volume after putting this bricks, these n number of bricks here, will be nothing but n into H2 L2 B2 n number of this B2 C. It is saying that each brick absorbs 1/17 of its own volume of water. See, this absorbs water means minus 1/17 of its own volume into N into H2 L2 into B2 plus original initial volume of water. This is total water under cistern, which is equal to nothing but volume of cistern, L into B into H. Now you can simply write it as L1 B1 into H1 equals VT is this, N into this. See, here it is also N, also 1/17, so you can simply write N into H2 into L2 into B2 common minus 1/17 plus Vi. Initial what is it is given in the question as 129,600. Yes. Now this is 1 minus 1/17 is 16/17. So you know these value. You know this. You know this. You know this. And you need to find. H is given. L2 is given. This is given. 1 minus 1/17. You can easily find. You can easily calculate. Vi also you are given. So this one can be calculated easily. Solve this to get the answer. Next question. If one fortnight of a given month, that is 15th day, there was a rainfall of 10 centimeter in a river valley. If the area of the valley is this much kilometer square, so the total rainfall was approximately equivalent to the addition of normal water of the three rivers, each this long. Yeah. Now next question is this is we are here at this rainfall of this, if the area of the valley is this much. So in that question it is like this. I'm assuming this is a, though not a river, assuming this area of this river is given like that. It is A1. Height of rainfall is given there. I'm assuming H1, which is also already given. A1 is 780 kilometer square area. Rainfall is this. Show that the total rainfall was approximately equal to the addition to the normal water of rivers, each this long, this wide, and this deep. Three rivers. H2, L2, W, or you can say B2. See, total rainfall is it is in kilometer square, so convert it into centimeters square. Why? Because H is given in centimeters. So volume will be of this river will be A1 into H1. Volume of original river. Volume of three such rivers will be L2, B2, H2. Since it is three rivers, this A river of 10 centimeter valley. If the area of the valley is this, show that the rainfall water corresponding to the addition of the water of 3 rivers, each this kilometer long, this meter wide, and this is in kilometer, so converted into length is in kilometer, so converted into meter. All units should be equal. This is in meter. This should be in meter. This should be also in meter. This should also be meter, meter, meter. Then only you can equate this. Now since this is you have to show this is equivalent, so if you calculate this, this will be in centimeter cube, and this will also come out to be in centimeter. This will come out to be this. Say so. This you can say that the equivalent rainfall will be equal to the addition of these 3 rivers. Solve this and get the answer. Next is a metallic right channel. Good. Yes, this is not this. Fifth question. The oil funnel tin consists of a 10 centimeter long. See, this is diagram is shown. 10 centimeter long cylindrical portion attached to a frustum of a cone. This, if the total height is 22 centimeter, diameter of this is 8 centimeter, and diameter of top is 18. Find the area of the thin sheet required to make the funnel. This is a simple question. This is not a good question. This is a simple question. This is given funnel. You have seen funnel at your home also. See, diameter is 18, it is 8, which means that radius will be 9 centimeter, 4 centimeter. R1, R2. So this is 4, this is also 4 centimeter. Circle, right circular cone. This is R2, this is also R2. So this height is given as H1, as a cylinder of 10 centimeters long cylindrical portion. 10 centimeter long cylindrical portion. Total height is given as 22, I think. 22 centimeter. Capital is equal to 22 centimeter. So you can easily find out the height of this much by subtracting this. H2 equals H minus H1 equals 12 centimeters. Find total area, find total sheet required. See, this is a funnel. This will be empty. Nothing here, nothing here, nothing here. So total area will be CSA of frustum plus CSA of cylinder. You already know that CSA of frustum is pi L R1 plus R2 plus CSA of cylinder is 2 pi R L. R is nothing but here R1. So you can solve, and this will be in centimeter square. Solve, put the values, solve and get the answer. Simple. Nothing special in this. This will be area of thin required to make the funnel. So derive the formula of the curved surface area and total surface area of frustum of a cone given to you in section 13.5 using the symbols as explained. Derive the formula volume of frustum of a cone given to you using the symbol as explained. Curved surface area and total surface area and volume. So I will try to solve in only one part of question only. See, you know frustum is made of 2 cones. First you need to know what does the formula looks like, or what does the formula is having. CSA curved surface area, you know, pi R1 plus R2L means that R1 R2 should be given. It is saying that in 13.5, section 13.5. Let us take on R1 is bigger. R1 is bigger. This is R1. This is R2. This is H. This is L. This area is pi R1 plus R2 L plus pi R1 square plus pi R2 square. Volume is 1 by 3 pi H R1 square plus R2 square plus R1 R2. Assume that is H dash. Now, right circular cone. These two are parallel. You must be knowing that from since these two are parallel, so you must have known the property of a triangle that H dash by H plus H dash equals R2 by R1, or H plus H dash by H dash equals R1 by R2. From here 1 plus H by H dash equals R1 by R2, which implies that find the value of H dash. H by H dash equals R1 by R2 minus 1, which implies right to here, H dash nothing but H by R1 minus R2 into R2. Now, additionally, you also know that L is H square plus R1 plus R1 minus R2 whole square under root. Using this. Now, what is the volume of this first term? Volume of this first term. This is volume of upper cone minus volume of lower. Volume of upper cone minus volume of lower cone. Volume of first term. Volume of upper cone minus volume of total cone minus volume of upper cone. Implies that V of S is total cone. You know that total cone height volume will be 1 by 3 pi. Here for total cone height will be H plus H dash. This for bigger cone, radius will be R1 and height will be H dash plus H or H plus H dash. Pi R1 square H1 H minus higher for upper cone, volume of upper cone will be 1 by 3 pi R2 square H dash. 1 by 3 pi R2 square H dash. Pi. This is H R1 square minus plus R1 square minus R2 square H dash. See, you know that H R1 square plus 1 square minus R2 square, what is H dash we have calculated? R2 by H, R1 by R2. R2 by H, r1 r2. This is a square minus b square equals a plus b. So from here you get that volume of first term is 1 by 3 pi h r1 square plus a plus b, a minus c gets cancelled, so r1 plus r2 into r2 h in nothing but 1 by 3 pi h. You can take common. This is r1 square from here and here. r2 into r2, this is r2 square from this plus r1 into r2. This is the answer. This is when you get the volume. Now you have to calculate the surface area of this. See, like same, if this is, you can assume this is L dash. Now L dash by L plus L dash equals R2 by R1. This is looking same. So solving this also, you will get that L dash is nothing but R2 by R2 into L by R1 minus R2. Now curved surface area of the first term, A of first term equal to CSA of total cone minus CSA of upper cone equals, you know, the curved surface area pi r L, r will be R2 or total cone will be, sorry, total cone will be R1 and L will be L plus L dash minus CSB of upper cone. Upper cone pi r will be R2 L dash R1. From here, if you take pi common, it will be R1 L plus R1 minus R2 L dash. Now you know that L dash equals nothing but R2 L by R1 minus R2. From above I have shown you this. So putting this value here, nothing but pi R1 L plus you can substitute this value as R1 minus R2 into R2L by R1 minus R2. So from R1 minus R2, R2 will get cancelled. And you can take this L common, pi L R1 plus R2. Simple. So this is curved surface area. For total surface area, you can simply write that curved surface TSA of the first term equal to CSA of the first term plus pi R2 square plus pi R1 square. If you add the two, pi, this will be pi L R1 plus R2 plus pi R1 square plus pi R2 square. So both of these questions is solved. Thank you for watching.